Hi, this is Jeff Spence, your Math 120 instructor for the Community College of Denver, and this is our video lecture over week 3 discussion set. So these first two are going to be a little difficult because I won't be able to actually complete the graph, but I'll be able to explain it and get the points. So the first one, we have the function f of x equals 3x plus 5. It says find each point and graph the function. So function notation works where you plug in a number, and that's the x value. And once you plug it in, you evaluate the expression, and that gives you a y value. So if I was going to do f of 2, that would mean I would have to do 3 times 2 plus 5, which gives me 6 plus 5, which is 11. So what that means is that I get the ordered pair, the point 2, comma 11. All right, and then let's just go through getting the rest of these. So 0, that means I plug in 0. So 3 times 0 plus 5. Well, 3 times 0 is 0, so plus 5 is 5. So that gives us the point. X is the input, 0. Y was the output, 5. And then the third one, f of negative 3. Oh, it's doing, there we go. F of negative 3, so we do 3 times negative 3, which is negative 9 plus 5. Negative 9 plus 5 should give us negative 4. So that's the y coordinate. So the x coordinate was negative 3. The y coordinate is negative 4. Oops, negative 4. Okay, now to plot these, I can't really plot this on this computer here the way I have it. You'll just want to write in the line here. So you want to plot these 3 points. Now if you look at this, the y coordinates are have a bigger range than just 5 if you count up. It goes 1, 2, 3, 4, 5. Remember, this is the x-axis, this is the y-axis. So maybe I'd want to scale the y-axis by 2. So 2, 4, 6, 8, 10. So when I plot the point 2, 11, I go 2 over on the x, 1, 2, and then 11 would just be just above that 10. So 2, 4, 6, 8, 10, and 11 I could plot maybe right there. So 2, 11 would be that point. 0, 5, so x is 0, so we're right here, 5. So we go up to 5, that's 2, 4, and 5 would be right there. So I'd have the first point here, the second point there, and then the third point is negative 3, negative 4. So negative 3 is 3 to the left on the x. Negative 4 is down 2 there because it's negative 2, negative 4. And there's our third point. So we have negative 3, negative 4, 0, 5, 2, 11. You have those 3 points and you connect them with a line and draw a line that way. The next one, x squared minus 1. So we plug in these values. So h of 1 means we're doing 1 squared. I'm just going to do 2 to the second power minus 1. So 1 squared is just 1. And if you subtract 1, then you get 0. So that gives us the point 1, comma 0. Second one, h of 0. So we're doing, plugging in 0. So we're doing 0 to the second power, also known as squared, minus 1. Well, 0 squared is 0, minus 1 is negative 1. So that gives us the point 0 for x, negative 1 for y. H of negative 1, let's see here, negative 1, quantity squared, minus 1. Negative 1 squared, I saw you guys make a mistake like this in the last discussion, I think. Some of you messed up the negative 1 squared. Whenever we square a negative, we get the positive number, because negative 1 squared means negative 1 times negative 1. So negative 1 times negative 1 is a positive 1. And positive 1 minus 1 is 0. So we get the point negative 1 for x. That's what we plugged in. 0 for y. And then the last one, h of 2. So we plug in 2. So 2 to the second power minus 1. 2 squared is 4. 4 minus 1 is 3. So that gives us 2, comma 3 as the point. Then we want to plot those points. 1, 0 would be 1, 0 right there. We plot that point. 0, negative 1 would be 0, negative 1 right here. So we have a point here. We have a point here. The next one is negative 1, 0. So negative 1, 0 is right there. So we have 3 points here, 1, 2, 3. We're starting to make a parabola because this is a quadratic function. When we see a quadratic, we have the x squared term. So making a quadratic, oops, sorry, it's down here, here, and here. And then the 2, 3, we go over 2 and up 3, 1, 2, 3. And you can see that it makes a parabola, and you can connect it that way, and it should look like that, like a U shape. Alright, next, it says use the graph to answer the following questions. So it looks like we're looking at the month and the price of gasoline. So generally gas is more expensive in the summer because we use more of it. So what was the approximate price in March? So I look at March, scan up. I'm going to say it was, so this is an interval of 12, okay? So I know it's right above 174. I'm not going to say 175 because it's an interval of 12. I'm going to give it 176. It doesn't. I know you're approximating this, so I need to make sure that you're, closer to 174. I would accept some other answers, but you have to be within. You have to be reasonable within your answer. You can get it wrong if you're way off. During which period were prices increasing? So it looked like from January all the way to June, prices were increasing. So January to June. So from here to here. Then it starts to decrease. Then it increases again one more time from September to October. So really this answer has 2 parts. From January to June and September to October is when the prices were going up. During which period were prices decreasing? So we're looking at this part and this part. So the first part is June to September. So June to September. And the other decrease is from November to December. November to December. Okay. Oops, sorry. To December. Alright, what month had the highest price? So we're looking for the highest price. It looks like right here. What month is that? June. What month had the lowest price? That would be obviously January. The lowest price. Okay. Now let's look at this one. This one's a little harder. Students tend to struggle with this, so please pay attention. Alright, we have the year and the number of tadpoles in a lake. Looks like it goes up and goes down and starts to increase slowly and go back down again. It says, what is the rate of change or slope from 1990 to 1992? So in the video, the lecture video I have, it says slope is rise over run. The rise means how much it changes vertically. Over run, which means how much it changes horizontally. The technical formula is y2 minus y1 over x2 minus x1. So I'm going to follow this formula. I'm going to let you know what points I'm using and then plug it in. So from 1990 to 1992, if we look at 1990, the year is 90 or 1990, but either way 90 is the x. The y value at 1990 is 200 tadpoles. So there's my first point. From 92 is the year, and the number of tadpoles was, this should be 14, so 1,500. Alright, so I'm going to follow this formula. If this is my x1, this guy down here is x1 and y1, and this second point is x2 and y2. Let me write that out. Okay, so I have them labeled now. So I have my first point and my second point. Now I'm going to follow the slope formula. So y2 minus y1, start with 1,500 minus 200 divided by 92 minus 90, which gives us 1,300 divided by 2, which gives us 650. Now it says give units. Now remember, the y, we're doing y divided by x. So the units for y are tadpoles, and the units for x are years. So just remember, whatever the units are for y, that's what you give, tadpoles per year. So the answer would be 650 tadpoles per year. The units are tadpoles, the y coordinate divided by the x coordinate. Alright, so I'm going to go through the formula again. I'm going to label my points. So it says, what is the rate of change from 92 to 93? Well, 92, we already know the point. So it was 92, 1,500. We used that from the last one. And then 93, The year is 93. The number of tadpoles here. So 200, I'm going to estimate, so yeah, 200. I'm going to say this is 300. If you said a little more, I guess that's okay. So it's 300. And it says give the units. Okay, so following the formula, the first point is my x1, y1 right here. Second one's my x2, y2. So I'm going to do y2, which is 300, minus y1, which is 1500, divided by x2, which is 93, minus 92, which is x1. So that's going to give me negative 1200 divided by 1. So that should give us negative 1200, or actually we should say a decrease, that's what the negative stands for, decrease of 1200 tadpoles per year. So don't forget the units at the end. Y divided by x, the y unit divided by the x. So a decrease, and I wrote decrease for the negative. What is the rate of change from 98 to 99? Okay, so let's look at 98. So the first point would be 98. What's the y coordinate there? Looks to be 600. And then 99. The y coordinate there is between 400 and 600, so it's 500. And we give the rate of change. So using the same formula, this is my x1, y1, x2, y2. So we're going to say, okay, y2, which is 500, minus 600, y1, divided by the difference in the x's, 99 minus 98. So that should give us negative 100 divided by 1. So the answer would be a decrease of 100 poles per year. Alright. Now, use your answer in part C to estimate the number of tadpoles in 2000 and 2001 if that trend continues. So the point is from 98 to 99, the decrease of tadpoles was 100 per year. So if the trend continues, from 98 to 99 it decreased 100. So if that trend continues from 99 to 2000, it should decrease 100 again. So it will go from 500 to 400. So in 2000, sorry about the editing here. So in 2000, the population will be 400. So we can give that point. 2000, the population will be 400. And then if it goes down 100 again in 2001, then it will be 300. So that's how you do that. Double check that, make sure that you're doing okay on this formula. Watch how I plug in the points. If it's a negative, you could say decrease. If it's positive, you want to write increase. But give the units. Remember when we do slope, it's y's divided by x's. So take the y units per the x unit and just write it like that. Good luck. See you next time.